Okay, students, today our learning objective is ratios, proportions, and geometric mean. Some of this you're going to remember from middle school because it hasn't changed, but we're just going to do a little review and then we're going to pick it up a notch and bring it up to the geometry level. All right, first of all, we're just going to start with ratio, the actual definition of ratio. And when we're talking about the ratio of A to B, we are talking about if A and B are two numbers or quantities, and B, of course, cannot equal 0, then the ratio of A to B is A over B. A ratio sometimes is written as a fraction. And the reason why B cannot equal 0 is because if it's in fraction form here, then our denominator can never be 0. Of course, there are three ways to write ratios, if you'll recall from middle school. A ratio with a colon, that's like A with two little dots, B, A colon B, and we read that as A to B. We call this the odds notation. And you'll see that a lot in gambling, or you might see it in the paper as the odds on the back of a lottery ticket, the odds of winning, or it could be, you also see this with baseball. Okay, here a ratio with the word to. You'll see it as A to B. And this we're just going to call the words notation. It's written in words. All right, and finally, the most common form is the fraction form. A over B. And we call that, of course, fraction notation. And if you see here, I put always simplify the fraction, or I'm sorry, always simplify the ratio in every single one of the boxes, because it doesn't matter which form it's in, you still have to reduce it. You're used to seeing ratios in fraction form. Here, I'm going to reduce the fraction. So here, 24 and 56, if I reduce that, I'm going to divide by 8. So 24 divided by 8 is 3, and 56 divided by 8 is 7. So this would be the reduced fraction, or the reduced ratio in fraction form. You can also write that as 3 to 7 with a colon, or you can write that as 3 to 7 in words. You're going to do 2, 3, 4, 5, and 6 by yourself, and bring those to class so we can check them to make sure that you have the right answers. Okay, in the next one, we have another vocab word, proportion. Proportion is an equation that states two ratios are equal. Now, this here that I have in this table, that is one of the 4 properties of proportions that you're going to learn in this chapter. This particular one is called the cross products. Cross products property. And it's the most common one that's used, and we use it to solve proportions, especially when there's a number that's missing. You'll remember this from middle school because we would circle these two, and then we would circle the next two, and we would say A times D is equal to B times C. And then we would just use our algebra skills to solve whatever letter or variable was missing. Okay, the next page. On the next page, we have several different proportions that we're going to work with. I'm going to work a couple, and then you're going to do some on your own. I'm going to work the first three, and you're going to work the second three. So the first one is just straightforward cross multiply or cross products. That's going to be 7 times x equals 12 times 5, or 7x equals 60. Dividing both sides by 7, I get 60 divided by 7, or 60 to 7 as a ratio. Again, you must always simplify, but remember this is a ratio, so we don't write it as a mixed number. We leave it in its improper form. Because remember, this is also written as 60 to 7 or 60 to 7. So you have to keep it in fraction form and not a mixed number. The next one, here we're going to find out what x equals, and then we're going to have to test it because we have an x in the denominator. And the only denominator, the only x value that will not work is 3. X cannot equal 3. If it does, that means that this denominator right here would equal 0. And you know from middle school that that is a no-no. You also know that from algebra, that that is a no-no. So here, we're going to cross multiply. That's going to be 3x times 2 equals 7 times x minus 3. This is going to give me 6x equaling, that's going to be 7x minus 21. I'm going to go ahead and subtract my 7x, even though that gives me a negative on this side. That's going to be a negative x equaling, because I already have a negative over here, negative 21. Multiply both sides by negative 1 or divide both sides by negative 1. It doesn't matter what you do. X equals positive 21. Now, you have to ask yourself, remember I told you you had to test it. Is this a proportion? So write that up here. Test it. Test your answer. Just to remind yourself that you have to do that. It's called a limit. Is this a proportion? Well, is 21, plugging that in here, minus 3, does that equal 0? Nope. 21 minus 3 definitely does not equal 0. So yes, this is a proportion and it is a solution. This is a solution. Okay, next one. Again, what value of x is not allowed? Here, our limitation, my limit, x cannot equal 3. If x equals 3, it's a no-no. We can't have that. So cross multiply, I get 2 times x minus 3, and I have a 3 times this x minus 3. Distribute. Now this is very important. You have to make sure that 2 is multiplied by everything inside the parentheses. 2x minus 6. Here, the 3 has to be distributed, so that's going to be 3x minus 9. When I solve this, I'm going to move this over to the other side, and I get I'm going to get, let's see, over here, if I add 9, that's going to be 2x plus 3 equaling 3x. Minus 2x, I get 3 equaling x. Uh-oh. That's what I said I couldn't have. So I know that since x equals 3, and that would make my denominator equal 0, that this has no solution. All right, you're going to do 10, 11, 12 by yourself. Okay, the next one, we have a couple more vocab words. First of all, we have the vocabulary words means and extremes. All right, here, in this proportion, A over B equals C over D, we can say that B and C are the means, and A and D are the extremes. All right, let's take an example so it's a little bit easier to figure out what's going on here. You know that 2/3, 2 over 3, well, that's the same thing as 30 over 45. So we know that this is a proportion, because if I multiply 2 by 15, I'll get 30. And if I multiply 3 by 15, I get 45. So you know this is a true statement. And I wanted to pick this one so that you could see that according to this definition, the 3 and the 30 are the means, and the 2 and the 45 are the extremes. Okay, well, take all of these numbers separately and just write them in order from least to greatest. The 2 is the smallest, so 2, comma, then you'll have a 3, and then you go to 30, and then you go to 45. If you take a look at the list of numbers, the two numbers on the end, 2 and 45, those are considered to be the extremes. They're the end points, they're on the outside. So the extremes. And the ones in the middle, these two in the middle, those are the means. Okay, so M means for middle, and then endpoints, extremes, E for extremes. So that's a way of memorizing that. The next one is going to be called the geometric mean. Okay, the geometric mean of two positive numbers, A and B, is the positive number x that satisfies this proportion, A over x equals x over b. So we're looking for the means, the ones in the middle. Okay, so here, if A over x equals x over b, then what do we really know? Well, we can take our property that we're very familiar with, our cross products, and we can cross multiply here. X times x is x squared, and that's going to be equal to A times b. But if I just want to find x, the geometric mean, then I need to take the square root of both sides. So that would leave me with x equaling the square root of A times b. Okay, so let's take a couple of examples. Okay, I'm going to do the first two, and then you're going to do the next four on your own, and make sure you bring those to class with you so we can go over and make sure that you understand it. Okay, remember from the other side, we know that x, the geometric mean, remember x was when we took the A and the B, the two numbers that they give us, we multiply them together, and then we take the square root of that. So here, x, the geometric mean, is going to equal the square root of 2 times 8. You just multiply the two numbers together. 2 times 8 is 16. So this is really just the square root of 16. So the geometric mean in this case happens to be 4. The next one's a little bit more difficult just because it's messier numbers, but we do it the same way. That's going to be 3 times 9, which is 27. And if you'll recall, we're not allowed to leave it. We have to simplify it. So remember, that's 3 times 9. Well, there's your perfect square. So you can write this as the square root of 3 times the square root of 9. And remember, that changes to a 3. We always write the 3 on the front. So x is going to equal 3 square roots of 3. And if I was asked to plug this into the calculator to give the approximated answer, you would plug it in as the square root of 27, enter, and you would end up with a decimal. Rounding the decimal, you get 5.201, so it's just going to be 5.2 when you round it. So these are your two answers here. This is my exact, this is my estimated answer, because we had to estimate. We had to round. Okay, 15, 16, 17, 18 are yours to do. All right, next it says the ratio of two side lengths for the triangle is given. The ratio is given. It's a 3 to 4 ratio. This one is a 7 to 4 ratio. Solve for the variable. Okay, they're saying A side AC compared to AB is 3 to 4. Here, I'm going to choose colors to try to help you understand this. So here I've got AC, which is this side here. When it's compared to AB, which is this side here, then this one, since it's first, it's going to match the 3. And this one here, since it's second, it's going to match the 4. So I set up my proportion. I'm going to put AC over AB, and the word is means equal. Remember, that means equal. And then I'm going to put 3 over 4. So the yellow ones go on top, and the pink ones went on bottom. Okay, now plug in the information that you know. So you're going to change those out, trade them out with the x and the 12. So here, that's going to be x over 12 equals 3 over 4, and cross multiply. Here I get a 4x equals 12 times 3. Well, 4x is 36. Divide by 4, divide by 4, so x equals 9. I'm going to have you do this one by yourself. Be careful here because you've got a 2x plus 4, so that means you're going to have to distribute. Alright, this next one, it makes it a little bit harder because we don't have a picture, so we're going to draw a picture. The area of the rectangle is 75 meters squared. The ratio of length to length is longer than width, so I'm going to let you know that that's 3 to 1. So it's 3 times as long. 3 to 1. Find the length and the width. Looking at that, it looks like we don't have enough information to find it. So here's my rectangle, here's my length, here's my width, and I know that the area is 75 meters squared. Well, what we do is we set length to width, that ratio, length to width, is going to be equal to 3 to 1. So, but we know that this side can't be 3, and we know this side can't be 1, because 3 times 1 would be 3, not 75. So I'm going to be multiplying 3 times some number x, and 1 times some number x. And this is the trick right here that you do. So here, my L is 3x, and my W is 1x. Now, area, remember, is length times width. So plug in what you know. Area is 75, so the A, replace the A with the 75. The length, we've set it up as 3x, and the width we set up as 1x. Okay, simplify the right-hand side. 75 equals, that's going to be 3 times 1 is 3, x times x is x squared. Divide both sides by 3. I get 25 equals x squared. Take the square root of both sides. X is going to equal, yes, that is plus or minus 5. However, because we're dealing with side lengths, you know it cannot be negative. So we're only going to focus on the positive, x equals 5. Okay, but we're not finished because it says find the length and width. Well, that's simple. We just plug it back in here. Length is equal to 3 times 5, which is 15 meters. And the width is going to be 1 times 5, or 5 meters. There we go. There's our length and our width. Number 22 is very similar. It's harder because there's not a picture. So you draw a picture. I have A, B, and C. What I know about this triangle is that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. That's from prior knowledge. It says the measure of the angles of a triangle are in the extended ratio of 11, 12, and 13. Okay, just like over here, when it was a ratio 3 to 1, I had to write 3x and 1x in my ratio. So over here, I'm going to do the same thing. My measure of angle A is going to be represented by 11x. My measure of angle B is going to be represented by 12x, and my measure of angle C is going to be represented by 13x. Now, when we added all these up, we got 180 degrees. So on this side, that's 180 degrees equals, we have to add all of these up. 11 plus 12 plus 13, that equals 36. So that's 36x. Divide both sides by 36, you get x equals 5. Okay, we're not done because we have to plug it back in to find out what the measure of each angle is. So here, I know that the measure of angle A is going to equal 11 times 5, which is 55 degrees. Measure of angle B is going to be 5 times 12, which is 60 degrees. And the measure of angle C is going to equal 5 times 13, which is 65 degrees. There's my answer. Find the measures of the angles of the triangle. Alright folks, that's it for note 6.1. Don't forget, you've got to go back and do all of those problems that I left you and bring them to class with you.